Download this code from codegive.com, link in the description below. Handling idle timeout with AWS NAT Gateway, a comprehensive guide. AWS NAT Gateway is a managed service that allows instances in private subnets to connect to the Internet, example for downloading updates, accessing external APIs, without exposing those instances directly to the Internet. It acts as a network address translator, forwarding traffic from instances in the private subnet to the Internet and then routing responses back to the corresponding instances. One crucial aspect to understand about NAT Gateway is its fixed idle timeout of 350 seconds, 5 minutes, 50 seconds. This means that if no traffic is exchanged on a particular TCP connection for 350 seconds, the NAT Gateway will drop the connection. This can be problematic for applications that maintain long-lived connections, such as database connections or interactive terminal sessions, if they don't actively send traffic within that time frame. This tutorial will cover 1. Understanding the NAT Gateway idle timeout. 2. The impact of the idle timeout. 3. Strategies to mitigate idle timeout issues. 4. Code examples for common use cases. 5. Monitoring NAT Gateway connections. 6. Troubleshooting idle timeout problems. 7. Alternative solutions. 1. Understanding the NAT Gateway idle timeout. The NAT Gateway's idle timeout is a mechanism designed to prevent resource exhaustion and maintain a stable service. It does this by freeing up connections that are deemed inactive. The timeout applies to TCP connections that pass through the NAT Gateway. It's important to understand that this is a fixed timeout, you cannot configure it. How it works *** connection initiation ** an instance in a private subnet initiates a connection to a public endpoint, example an external API, a database server. *NAT Gateway translation ** the traffic passes through the NAT Gateway, which replaces the instance's private IP address with its public IP address. *idle time tracking ** the NAT Gateway starts tracking the idle time for this connection. Idle means no data is being sent or received on the connection. *timeout expiration ** if the connection remains idle for 350 seconds, the NAT Gateway drops the connection. Connection closure * the NAT Gateway sends a TCP RST, reset, packet to both the client, private subnet instance, and the server, public endpoint, to signal that the connection is closed. Important note * the NAT Gateway idle timeout only applies to TCP connections. UDP connections, for example, do not have this fixed timeout. However, UDP connections are generally less stateful and handle packet loss differently, so the timeout issue is less common. 2. The impact of the idle timeout. The idle timeout can manifest in various ways, leading to unexpected application behavior. Connection loss * applications might unexpectedly lose connections, requiring them to reconnect. This can disrupt operations, especially for real-time applications. Data loss * if data is buffered but not actively transmitted when the timeout occurs, that data might be lost. Performance degradation * frequent reconnection attempts can add latency and overhead, degrading application performance. Error messages * applications might throw connection errors, such as connection reset by peer, timeout, or broken pipe. Intermittent failures * the impact can be intermittent, making it difficult to diagnose the root cause. Example scenarios ***. Database connections ** an application maintains a persistent connection to a database server outside the VPC. If the application doesn't actively query the database within 350 seconds, the connection will be dropped. Asterisk interactive terminal sessions, SSH. An SSH connection to a server in a private subnet through a NAT gateway might be disconnected if there's no activity for 350 seconds. Asterisk long polling APIs. Asterisk applications using long polling APIs, where the server holds the connection open until new data is available, are particularly vulnerable because the connection might remain idle for extended periods. Asterisk keep alive mechanisms. Asterisk even with keep alive mechanisms built into protocols, they might not be frequent enough. Example defaults might be longer than 350 seconds. 3. Strategies to mitigate idle timeout issues. The key to mitigating NAT gateway idle timeout issues is to ensure that traffic is actively sent and received on connections before they are dropped. Here are the most common strategies. Asterisk TCP keep alive. Asterisk purpose. Asterisk TCP keep alive is a mechanism that periodically sends probes to keep a connection alive. It's configured at the operating system level. Asterisk how it works. Asterisk the operating system sends small TCP packets to the peer to check if the connection is still active. If the peer responds, the connection is considered alive. Asterisk configuration. Asterisk you need to enable and configure TCP keep alive on both the client, instance in the private subnet, and the server, external endpoint. The keep alive interval must be less than the NAT gateway's 350-second timeout. A common recommendation is around 60 seconds or less. Asterisk Linux, client-side example. Asterisk Windows, client-side example, requires registry edits. Asterisk caveats. Asterisk TCP keep alive is a relatively low-level mechanism. It only verifies that the connection is still technically alive at the TCP layer. It doesn't guarantee that the application at the other end is still responsive or that the data path is fully functional. Some firewalls and network devices may interfere with TCP keep alive probes. Asterisk application level keep alive. Asterisk purpose. Asterisk send application-specific heartbeat messages or perform periodic operations that keep the connection active. This is often a more robust solution than TCP keep alive. Asterisk how it works. Asterisk the application itself periodically sends data over the connection. This data could be a simple ping, a status update, or a small piece of actual application data. Asterisk implementation. Asterisk this requires modifying the application code. Asterisk advantages. Asterisk more reliable than TCP keep alive because it verifies the application layer functionality. Asterisk disadvantages. Asterisk requires modifying the application. Asterisk connection pooling / reusing. Asterisk purpose. Asterisk minimize the number of connections that are kept open for extended periods. Asterisk how it works. Asterisk use connection pools to reuse existing connections instead of creating new ones for each operation. This reduces the likelihood of connections remaining idle. Many database connection libraries provide built-in connection pooling. Asterisk configuration. Asterisk configure the connection pool to discard idle connections that have been inactive for a certain period, less than 350 seconds. Asterisk connection management in load balancers, if applicable. Asterisk if you're using a load balancer, example ALB, NLB, in front of your instances, ensure that the load balancer's idle timeout is also configured to be less than the NAT gateway's timeout. The load balancer can terminate connections before they reach the NAT gateway's timeout, preventing issues. Asterisk scheduled tasks or periodic jobs. Asterisk if your application performs infrequent tasks that require a connection through the NAT gateway, schedule these tasks to run more frequently. This keeps the connection active. For example, you could schedule a script to ping an external server every few minutes. Asterisk increase activity. Asterisk design your application to actively send data periodically, even if it's just for monitoring or logging purposes. This is similar to application level keep alive, but involves sending real application data. 4. Code examples for common use cases. Here are code examples demonstrating how to implement application level keep alive in common scenarios. Asterisk Python, using requests library, for HTTP requests. Explanation asterisk. 1 keep underscore alive, session, URL, interval, function asterisk. Asterisk takes a requests.session object, for connection pooling, the API URL to ping, and the keep alive interval as arguments. Asterisk continuously sends a GET request to the specified URL. Asterisk handles potential requests.exceptions.request exception errors. Asterisk sleeps for the specified interval before sending the next request. 2 main, function asterisk. Asterisk creates a requests.session object. This is important for connection pooling and reusing connections. Asterisk starts the keep underscore alive function in a separate thread using threading.thread. The daemon equals true setting allows the main thread to exit even if the keep alive thread is still running. Asterisk your main application logic goes here, making other requests using the same session object. This ensures that the keep alive traffic helps maintain the overall session through the NAT gateway. Asterisk handles keyboard interrupt to allow graceful termination. Asterisk closes the session object in the finally block to release resources. Asterisk Java, using JDBC, for database connections. Explanation asterisk. 1 db underscore URL, db underscore user, db underscore password asterisk replace with your database connection details. 2 connection asterisk a connection object to the database. 3 scheduler asterisk a scheduled executor service to schedule the keep alive task. 4 main, method asterisk. Asterisk establishes a connection to the database using driver manager.get connection. Asterisk calls schedule keep alive, to start the keep alive task. Asterisk contains the main application logic that uses the database connection. This example simulates the application running for 5 minutes. Asterisk closes the database connection and shuts down the scheduler in the finally block. 5 schedule keep alive, method asterisk. Asterisk creates a scheduled executor service that runs a task at a fixed rate. Asterisk the task executes a simple SQL query, select 1, to keep the connection alive. This query doesn't return any data but ensures that traffic is sent over the connection. Asterisk the schedule at fixed rate, method schedules the task to run every 120 seconds, 2 minutes, which is well below the NAT gateway's 350-second timeout. The initial delay is set to 0 to run the task immediately upon startup. Key points asterisk. Asterisk connection pooling asterisk for more robust database interactions, consider using a connection pool, example using libraries like Hikari CP, Apache Commons DB-CP, instead of creating a new connection each time. Connection pools can manage a pool of connections and reuse them, improving performance and reducing the overhead of connection creation. Asterisk exception handling asterisk the code includes proper exception handling to catch SQL exceptions that might occur during database operations. It's essential to handle exceptions gracefully and log any errors for troubleshooting. Asterisk resource management asterisk the code uses a try with resources statement, try, statement equals connection.create a statement, to automatically close the statement object after it's used, preventing resource leaks. Asterisk node.js, using node fetch, for HTTP requests. Explanation asterisk. 1 Node Fetch *. This is a modern fetch API for Node.js, similar to the browser's fetch. Install it using npm install node fetch. 2 Node Schedule *. This library allows you to schedule tasks to run at specific times or intervals. Install it using npm install node schedule. 3 API_URL *. Replace with the URL of the API endpoint you want to ping to keep the connection alive. 4 Keep alive function *. Sends a GET request to the API_URL using node fetch. * Checks the response status and logs any errors. 5 Schedule.schedule job /2 ****, keep alive ***. Uses node schedule to schedule the keep alive function to run every 2 minutes. The cron expression *2**** means run every 2 minutes. 6 Job.cancel * cancels the scheduled task when the application is finished. 5. Monitoring NAT gateway connections. Monitoring your NAT gateway connections can help you identify potential idle timeout issues and fine-tune your keep alive strategies. CloudWatch metrics AWS provides several CloudWatch metrics for NAT gateways, including bytes into out the number of bytes transferred from the instances in your private subnets to the internet through the NAT gateway. Bytes out to in the number of bytes transferred from the internet to the instances in your private subnets through the NAT gateway. Connection established count the total number of connections established through the NAT gateway. Disconnect ions the number of connections dropped by the NAT gateway. An increase in this metric could indicate idle timeout problems. Error port allocation indicates the NAT gateway is running out of ports. This can be a symptom of improper connection management. VPC flow logs enable VPC flow logs for your VPC to capture information about the IP traffic going to and from your network interfaces. You can analyze these logs to identify connections that are being dropped, and correlate them with the NAT gateway's idle timeout. Use CloudWatch Logs Insights or other log analytics tools to query and analyze the flow logs. Application logging implement detailed logging in your application to track connection status, errors, and keep alive activity. Correlate application logs with CloudWatch metrics and VPC flow logs for comprehensive troubleshooting. Example CloudWatch Logs Insights query, VPC flow logs. This query identifies TCP connections reset, RST, by the NAT gateway within the last 5 minutes. Replace your NAT gateway ENI with the actual network interface ID of your NAT gateway. You can find the ENI ID in the AWS Management Console in the EC2-Network Interfaces section by filtering for description that contains NAT gateway. 6. Troubleshooting idle timeout problems. When troubleshooting potential idle timeout issues, follow these steps. 1. Verify the symptoms * confirm that the application is experiencing connection drops or unexpected disconnect ions. 2. Check CloudWatch metrics * examine the disconnect ions metric for your NAT gateway in CloudWatch. A significant increase could indicate timeout issues. 3. Analyze VPC flow logs * use VPC flow logs and CloudWatch Logs Insights to identify the dropped connections and their characteristics, source/destination IP addresses, ports, TCP flags. Look for connections that are being reset, RST. 4. Review application logs * check the application logs for connection errors, example connection reset by peer, timeout, broken pipe. Correlate the timestamps of these errors with the VPC flow logs and CloudWatch metrics. 5. Test keep alive configuration * if you're using TCP keep alive, verify that it's correctly configured on both the client and server. Use Dump or Wireshark to capture network traffic and confirm that Keep Alive probes are being sent and received. 6. Test application level Keep Alive *. If you're using application level Keep Alive, verify that the heartbeat messages are being sent and received at the configured intervals. Use network monitoring tools to inspect the traffic. 7. Adjust Keep Alive intervals *. Experiment with different Keep Alive intervals to find the optimal setting that keeps the connections alive without introducing excessive overhead. Remember to keep the interval significantly below the 350-second NAT gateway timeout. 8. Consider connection pooling *. Implement connection pooling to reuse existing connections and reduce the number of long-lived idle connections. 7. Alternative solutions. If you're unable to effectively mitigate the idle timeout issues using the strategies described above, consider these alternative solutions. * Direct internet access. If possible, if security constraints allow, you could assign public IP addresses to your instances and allow them to connect to the internet directly without using a NAT gateway. This eliminates the NAT gateway's idle timeout. However, this approach increases the attack surface and requires careful security configuration. * VPN or AWS Direct Connect. * Use a VPN connection or AWS Direct Connect to your external resources. These connections often have configurable timeouts, giving you more control. However, these solutions are typically more complex and expensive. * Proxy servers. If applicable for certain use cases, example web traffic, you could use a proxy server that handles the connections to external resources. The proxy server can manage the Keep Alive logic and hide the individual instances' IP addresses. * Redesign application. * The most drastic solution is to redesign your application to use a connectionless protocol, example HTTP/1.1 with short-lived connections, or to minimize the need for long-lived connections. This might involve architectural changes and is not always feasible. Conclusion. Handling the NAT gateway's fixed idle timeout requires careful planning and implementation. By understanding the problem, employing the right mitigation strategies, TCP Keep Alive, application level Keep Alive, connection pooling, and monitoring your connections, you can ensure that your applications running in private subnets can communicate reliably with external resources. Remember to prioritize application level Keep Alive when possible, as it provides a more robust solution than TCP Keep Alive. Proper monitoring and logging are essential for identifying and resolving any timeout-related issues. If all else fails, consider alternative solutions that might be more suitable for your specific use case.